All right. Hello, everyone. My name is Alexander Hernandez, and I'm going to be presenting my Capstone project, which was fraud detection using random forest machine learning algorithm. All right. So here's on the agenda. We're going to talk about what random forest is, why did I decide to do fraud detection, our preparation for the code breakdown, statistics, the improvements, and the summary. All right, so what is random forest? Random forest is a machine learning algorithm that uses many decision trees to make better predictions. Each tree will look at different random parts of the data, and the results are combined by voting for classification or averaging for regression, which makes it as an ensemble learning technique. So you're going to have a whole buttload of these decision trees that are each going to take different random features from the data set, which makes each tree unique, or at least a little more unique, and it does kind of scale. So if you have only a little bit of features, it's not going to be as good. If you have a lot of features, it's going to be really good and really decisive on that majority voting. And then once it comes down to a conclusion, each tree will make its own conclusion, and the majority vote for that conclusion will be the actual conclusion. Using random data and features for each tree helps avoid overfitting and makes the overall prediction more accurate and trustworthy. All right, so we're gonna go through the workflow. Kind of already explained it. So you're gonna have a lot of these decision trees, which you have to create. You're gonna pick random features from the data. So in our case, I had transaction amount, average transaction amount, currency type, transaction type. You're just gonna pick random features from that set, and then you're gonna say, all right, do you think this is a scam? Each tree is going to ask this question: is this a scam based on these features? Yes or no? And then the majority voting, after all that's done, said and done, is going to be the actual prediction, which is that combining predictions part. We have an example. So this model, which is a, model that determines if someone will buy a product, which is kind of similar to my fraud case because it has a yes or no section, which is the select feature. Pretty much says um, if they bought a product, yes or no, and then that feature is what determines like the accuracy and whatnot. And then it takes in all these other inputs like age, income, pages visited, and then we have a little example where a new customer, age 35, medium income, 3 pages visited, and then each tree votes, and then comes on the conclusion that yeah, they're gonna buy that product. All right, why fraud detection? I grew up in a very financially smart home where my mom worked in banks and credit unions the majority of her life, and she still is to this day. She's working with banks and credit unions. And so we had a lot of conversations about fraud detection, or not fraud detection, but just fraud in general. What happens if someone gains access to my bank account? What happens if my bank account gets drained and I have no idea why? These are the type of things that these are the type of things that I feel um, credit unions and banks always try to help reduce because fraud is bad and we don't like fraud. And I have a couple statistics here. And as you can see, so I think at least a part of these statistics were taken from Forbes, and this graph specifically was taken from Forbes magazine. Uh, Shows a steady increase from 2020 to 2025 of wire transfers, and as you can see, they're going up pretty consistently. Also, my previous experience in fraud detection with microservices at my internship with Algebraic AI, that's pretty much where I got this idea of fraud detection because Algebraic AI works with credit unions and banks, small credit unions and banks. And I thought it would be kind of fitting to do a fraud detection service with kind of an AI wrapper. I built everything around the AI and then I used an API key to call an AI to determine it. And yeah, I thought a random forest would be much more um obviously more technical for something that I am trying to do for a capstone. And I think it would fit a lot better since it can decide pretty accurately with reducing overfitting. All right, and then I had to prepare. So, um, to determine the entities, I created like a large list of entities, and then from that list, I decided on transaction amount, average transaction amount, customer location, recipient location, transaction type, and currency type. I had timestamp as a feature, as an entity. But what happened was when I was trying to parse the non-numerical data in the code, and then I ended up having a lot of problems where I just put it on the back burner and then eventually just took it out because I wasn't using it, which is a good and bad thing. Good for performance and getting it turned in on time, but bad for it lessens the amount of features, which lessens the accuracy of the random forest algorithm. And then I had to obtain the data. So the data was originally produced on a website, but that data ended up being really, really bad for the algorithm because it was all 50-50. Like everything was randomly produced, even the um, true or false section of the is fraud. So it really messed with the AI and gave me 50% on the learning curve every time, which is not good. Pretty much every time, 50% of the time is a fraud. That's not good. So I had to backpedal, and unfortunately I did turn in um something that had that data, but since then I fixed it and it is now using data that more accurately represents what it should be doing. More accurately represents real world data, I should say. Then I created a UI through Visual Studio Features, and I even made a little gauge wheel, which we'll go over, and then create Navi. So instead of saying random forest machine learning algorithm this entire time, I just decided to call it a name because it learns and it's cool and I like it. So it's called Navi. Navi was built using Microsoft's Fast Forest Binary Trainer class through their ML library. Um, yeah, and then we'll go over that in a little bit, and then we just determine the results. All right, code breakdown. I'm gonna go through this, and then we're gonna go to the code. We're gonna test it out a little bit, and then show you the ins and outs. So we're gonna load the data from the CSV, which part of the reason why I was having issues was because of the CSV. Formatting issues was a problem, and I had a couple other things, but that's all in the past now. We had to create a transaction data class, which is pretty much the set feature list, and then the data was not cleaned. I'll go over that later. It was shuffled. The data was shuffled to ensure consistent results through randomness. I called the Microsoft ML library forest trainer and then determined its options through tree size, leaf size, column name, and then I evaluate and test the set through um, area under the curve, F1 score, accuracy, and more. And then I'll make Navi a library for the UI to call, and I'll go over that now. All right, now we're gonna go over the code. I might cut in between because for some reason Visual Studio likes to crash whenever I switch it from a console application to a class library. But we'll go over this. So this is our program that trains the model. As you can kind of see from where I was at in the PowerPoint, we load the data from the CSV, clean and shuffle it. I was cleaning it, but I decided just to trust my data instead, which was a fine idea now. But if you were to ask me with this data set that I had, I probably should have cleaned it. So there was that. And then we split the data, shuffled the data, then split the data. And then we created our pipeline through the ML library. And then this is pretty much just converting those non-numerical values into something the computer can read. We plug the trainer, plug this classification, this is the fast forest. This is just determining the options. So 100 trees, 20 number of leaves, zero point 0.7 feature fraction. Put it through the pipeline, and then it trains the model through that split train set that we had. And then we'll save the model to a zip file. And the rest of this we'll get into when we run it. And this is another important, this was the transaction data. These are our feature, except this. This is just to say at the end of it if it actually was a fraud or not, which was a risk label. And then here's our CSV, which is now finally in the right format. And we'll scroll all the way down here just to prove that I do have 10,000 lines of data. But yeah, That's what this is. So then we'll start it up. We'll let it do its thing. And as you can see, it prints out a huge kind of confusion matrix-esque thing here. So as you can see through these test results, so this one it kind of got wrong. Not kind of, it did get wrong. So it said it was like a 62% chance of it being a fraud. Sorry, not a fraud. And it ended up being a fraud. But this one was right. Not a fraud, not a fraud. 2% chance of it being a fraud. This one was wrong, unfortunately. This one's right, this one's right, this one's right. So yeah, and it goes on and on and on. And there was 1,900 that were fraud and 8,000 that was not fraud, which I don't think I got there yet. But it was about a 19% of not fraud and then 81% fraud. Or sorry, 81% not fraud, 19% fraud. And then, oh, I didn't go over this, the sample transaction. So this is not correct. I don't really know what's happening here. It gives us a confidence score of 100%, which is not really right through a learning model. AI should never be 100% right. We have our model metrics, which we'll get into 88% accuracy, 92% under the area curve. Sorry, area under the curve, which is pretty good. These are good. F1 score and recall, however, if you know machine learning algorithms pretty well, you could probably already understand what's happening here, which we'll get into later. And then our confusion matrix, almost 800 true positives, which is good. 113 true negatives, which is good. False positives, this is okay. I'd rather a false positive over a false negative. False positives is fine. False negatives is bad. If the lower this number is, the better. All right, and then we'll get into the UI. Hopefully this doesn't crash. All right, it didn't crash. That was awesome. Then we will test our UI. This our UI. We have a low risk gauge here. And I did end up just leaving the timestamp because I like the calendar that Microsoft Visual Studio has. It's cool. So I left it in there. Let's do a prediction. So let's say I have 1,000. I send out $1,000. My average transaction is 2,500. I'm in. No, we won't say Paris. I'm in New York. I send it out through USD. The recipient, however, is in Mexico City, and the transaction type is a refund. So refund, there's a very common fraud called a refund fraud, obviously. So we'll see what that says. And like it shows, 90% risk. Let's see if it can give us a normal number. Let's see how it does with New York to New York through a purchase of USD. Says it's a fraud. That is probably not right, but that's okay. Let's say my average transaction is 25,000. Still says it. I was testing this earlier. I think it has a problem with New York. It does not like New York. Let's do London to London. Actually, we'll do London to Sydney through euros. And then we'll send this down to $100. I don't know what is happening today. I wasn't doing this earlier, which is really weird. I think it's the purchase. For some reason, it thinks purchase, because if I do refund, it says low risk. I do purchase, it says high risk. It's interesting. Payment, however, that should be low risk. That's pretty good. So yeah, I'll do one more. Maybe we can get it in that medium range. Let's send it to Mumbai through some random currency type. We'll do 200. Same transaction type. Okay, it's definitely more. I don't really know what this currency type is. Maybe we change this to like a reimbursement. Okay, went up. Fee went down. Fee is usually less. Exchange, transfer. Okay, one more. Donation. Donation should be pretty low anyways. All right. But yeah, that's how that works. So we'll get back to the presentation. All right, let's get into the statistics of Navi. So, as I said through the code breakdown, there was a pretty outstanding issue, which sucks. It's it's an issue, but it still learns correctly, so it's kind of there. Core performances, we already went through the confusion matrix. Data distribution, 1900 fraud. Not fraud, it was 8,000. That's about a 19% fraud chance. 88% accuracy, which is good. 92% area under the curve, which is pretty good. 74% precision. It's okay. It's all right. Recall and F1 score, however, pretty bad. And we'll get into this here through the improvements where I kind of state what's happening. So it's having an issue with class imbalance. So it was 19% fraud cases. It struggles to determine fraud examples because it sees fewer of them. So that is something I could improve to it. I could definitely do more fraud cases. I could also give it real data, which is also something that I kind of mentioned is I don't think synthetic data was maybe the best thing. It's something good that I could test it on to see it actually works. But synthetic data at the end of the day is synthetic data. It's not real. Um, so that could also be a problem. Um, but yeah, the class imbalance almost makes Navi look like a little cheater because about 50% of the time, or about 60% if I were to round up, if it's a fraud, it says so the majority voting was not fraud. So if it's a fraud, it goes 50-50 on fraud or not fraud, which is bad. That's not good. Um, so yeah, it's a little bit of a cheater, but it's okay. We'll fix it up. The improvements could be to penalize these mistakes, which I really want to add into it, reducing the non-fraud cases, and then threshold tuning. And then we're finally towards the end to our summary. Navi is designed to detect fraudulent transactions by analyzing patterns in transaction data and predicting whether an activity is likely a scam or legitimate. It is useful in scam prevention systems such as banking and online payments, where it helps flag suspicious transactions for review or blocking in real time. With better handling of data imbalance, feature refinement, and threshold tuning, the model has strong potential to become more accurate and reliable in real world fraud detection systems. Navi, in my opinion, it's my first AI that I built, so I'm kind of giving it some grace, but it has great potential, and I think if we can kind of invest in this fraud detection, we can make that graph seen by Forbes magazine go down, consistently go down. However, um, I mean, fraud will always be there. Someone is always trying to scam someone. Um, that's unavoidable. What is avoidable is taking, sorry, what is able to be done is taking time out and producing these systems to detect these real world fraud cases. Even testing on synthetic data is better than having nothing. So yeah, that was my capstone project. Here are my references. Oops. Here are my references, and thank you.